Welcome to Pristine Maths Club. Like, comment, and subscribe. Motion. The equations of motion. Oh, the first one. But there are four equations to note. The first one is V is equals to U plus 80. Second one, S is equals to UT plus half AT squared. The third one is equals to V squared is equals to U squared plus 2AS. The last one is equals to S is equals to V plus U into bracket T over 2, where U is equals to initial velocity is measured in meter per seconds. V is equals to final velocity is measured in meter per seconds as well. A is equals to the acceleration is measured in meter per second square. While you have the T is equals to the time is measured in seconds. S is equals to distance covered is measured in meter. Okay, note these four formulae. Motions of bodies under gravity. Neglecting air resistance. Motion of bodies moving under gravity, either vertically upward or downward, is an example of uniformly accelerating motion. When we say uniformly accelerating motion, we are saying the acceleration is uniform, which is equals to g, that is acceleration due to gravity. The first one we are going to look under this, a body thrown vertically upward in the Earth gravitational field. We shall derive formulae for maximum height, time to reach maximum height, and total time of flight. Okay, under this, a body that is thrown vertically upward. Let's look at the body here. The initial velocity is to be thrown with initial velocity u. Okay, as it's moving up, the velocity will be decreasing. The initial velocity will be decreasing. It's maximum when it's first thrown, so the initial velocity will now be decreased as going up. So when you reach the height here, it will now be equals to 0. It's no more moving. So at the maximum height, the final velocity is equals to 0 now. So, okay, and we have our h there, that is the height. S is equals to h. Distance, okay, is equals to h. Acceleration due to gravity is equals to minus g because it's thrown against gravity. Okay, now we use one of our formula for the equation to get the maximum height. Okay, the formula we shall use is equals to v square is equals to u square plus 2as. Okay, so we already know that our v is equals to 0, so we put the 0 there. The u square, we have it, that is the velocity of projection with the initial velocity, and the acceleration there is minus g because it's thrown against the gravity, so it becomes minus 2g now. Okay, the s here give us the h. Okay, that is the height. So we take minus 2gh to the other side. So it gives us plus 2gh. Okay. So we have the 2gh is equals to u squared. Okay. We are to get the maximum height. So we divide everything by 2g by 2g. So the maximum height h, okay, will be given as u squared over 2g. That's for a body that is thrown vertically upward. We want to get the time to reach the maximum height. To get the time to reach the maximum height, we use the formula v is equals to u plus 80. Okay, don't forget the final velocity is equal to 0, initial velocity, minus gt, because a is equal to minus g. We take the minus gt to the other side, so we have the gt, okay, is equals to u. Dividing by g, we have t is equals to u over g. That is time to reach the maximum height. Roman figure 3, the total time taken. So let us look at it. Suppose it takes 2 seconds from the ground to reach the maximum height. So from the maximum height to reach the ground again, it will also take 2 seconds, for example. So meaning that the total time of flight now will now be equals to 2u over g. That is 2 times the time to reach the maximum height. So these are the 3 formulae that are needed when a body is thrown vertically upward. Okay, number 2. For a body, motion of a body is falling freely under gravity. Okay, we shall derive formulae for velocity of the body just as it is about to reach the ground to time to reach the ground. Okay, suppose we have this body here. Up there, the initial velocity is equals to 0. So, and it's falling down. Okay, at the final velocity there, it will have a maximum velocity down there because the velocity will be increasing, that is falling down. The height is equals to h. Acceleration due to gravity is equals to g. This time around is not falling against gravity, okay, because it's falling down. Okay, we use the formula v square is equals to u square plus 2as. Okay, that's the formula we are using. Okay, v square is equals to u is equals to 0, we put it there, plus 2g, a is equals to, because it's a uniformly accelerating motion, and s equals to h. So you have v square is equals to 2gh. V is equals to the square root of 2gh. That's the velocity of the body just as it is about to reach the ground. Time to reach the ground now, which is Roman figure 2. Using the formula of s is equals to ut plus half at squared. Of course, s is equals to h. You put the h there, equals to initial velocity is 0. Everything there is 0. Okay, plus half the g there, a become the g, and we have t squared. Okay, so gt squared now over 2 is equals to h, and we can cross multiply now. Gt squared is equals to 2h. We divide everything by g, so we have the t squared is equals to 2h over g. Okay, so to get our t now, we square root both sides, so we have 2h over g. That is the time it takes to reach the ground. Example 1. A projectile is fired vertically upward and it reached a height of 78.4 meters. Find the velocity of projection and the time it takes to reach the highest point. Of course, if a projectile is fired vertically upward, so we have derived the formula to get the velocity of projection, which is equals to u in this case. So using the formula h is equals to u square over 2g, the formula we have gotten earlier on. So the h is equals to 78.4 meters. Now u is what we are looking for. That's velocity of projection, which is initial velocity. Acceleration due to gravity is 10 meters per second. So the h is equals to 78.4 there is equals to u square over 2 times 10. Okay, u square is equals to, we cross multiply 20 times 78.4. U square is equals to, we multiply 20 times 78.4, 1568. So u is equals to the square root of 1568. So we get the final answer for the u to be equals to 39.6 meters per second. Now to get the time it takes to reach the highest point, so we use the formula of the t is equals to u over g. Okay, that's the t we are looking for. So the time it takes, so when a projectile is projected vertically upward, time it takes to reach the highest is t is equals to u over g. The velocity of projection is what we have gotten, 39.6 is our u over g, which is 10. So the final answer here is equals to, t is equals to 3.96 seconds. Okay, so that's our final answer for the 2 there. Let's look at this example 2. A body falls from a height of 80 meters. Okay, fall from a height. What is its velocity just before hitting the ground? The velocity we got in this case is v is equals to square root 2gh when a body falls down. So our h is equals to 80 meters. V is equals to square root 2gh now is the velocity before it's reached the ground. 2 times 10 times h is equals to 80. 2 times 1, v is equals to square root 1600, v is equals to 40 meters per second. Example 3. A stone is dropped from a height of 196 meters. Neglecting air resistance, calculate the time to reach the ground. Okay, the height is 196 meters since it's dropped from a height. Okay, the total time taken is what we will look at now, which is equals to square root 2h over g when it's dropped from up. So you plug everything inside our formula. 2 times 196 divided by 10. So we get t is equals to the square root of 392 over 10. We have t is equals to square root of 39.2. T is equals to 6.26 seconds. Let's look at the last example there. A ball bearing is projected vertically upward from the ground with a velocity of 50 meters per second. Okay, from the ground with a velocity of 15 meters per second. Okay, we use the formula, the time taken by the ball to return to the ground is projected vertically upward. So in this case, we're using the formula t is equals to u over g to get up, but for coming down also as well, it's also use another u over g. So the total time of flight is equals to 2u over g. Okay, so t is equals to 2 times initial velocity is 15 is given to us over g, which is 10. T is equals to 30 over 10, which is equals to 3 seconds rather.